All right. Hello. First, I'll introduce myself. My name is Brett, as he just said. I work at RDO, and I've been there for about 4 years, and I've been working on the Android app for about 3 of those years. Now that's out of the way, let's talk about RecyclerView. I think the first thing I should do is sell you on it. So why should you use it? Because you probably already have an app, it's written, it's probably using ListView or GridView or something like that. But I almost guarantee you probably run into problems with it or run up against some serious limitations as your app evolves and you want to make a more complicated UI. Especially GridView starts falling short really quickly. So that's why RecyclerView is coming to your rescue. They announced it last year's Google I/O, 2014 Google I/O, they announced the RecyclerView. And I don't think a lot of people have really started adopting it yet, although it has been getting incremental updates in each support library revision. And I really think it's the future, and that's where most of the Android engineering work is going to go into RecyclerView, and probably not so much into the legacy list views. But let me show you an example here of something that maybe you've tried to do in the past, or your designers asked you to do in the past, and it's really hard to do with a grid view. So you have a grid here with a header that's part of the content, not just a header that's above all the content or a footer that's below all the content, like the way that ListView headers and footers work. It's in the middle here. This grid has 3 columns, but you want this item to span all of them and be full bleed. And then maybe you want to have some items that are a little bit bigger because maybe they're more important or whatever. And so this is going to span 2 columns, and then everything needs to flow around it. Now the current grid view doesn't do this at all, really. You can implement a header grid view if you want, but it really does headers and footers that surround the content. It's hard to get it to be part of the content. But with RecyclerView, it's very easy to do something like this, and I will show you in just a bit. But I think a video or live demo is going to be more exciting than just looking at a static picture. So I'm going to bring up the Genymotion Emulator, give those guys a shout out. They have a booth downstairs, and I've been using Genymotion for like a year, and it's pretty awesome. So here's the demo. We start out with just a standard list. It's pretty normal. It's got some headings. So this is a RecyclerView, and it does pretty much what the normal list view does. I've added a little bit of an animation to the bottom. That's not part of RecyclerView, but it kind of makes the scrolling a little bit nicer, and it's a little kind of more materially. The source code for this demo is on GitHub. The link is at the bottom of every slide, so you can see how I did that animation. I'm not really going to go into that during this demo. Okay, so this is kind of a standard. Okay, it's a list. It's got some headings in between the groups here. Let me get down to it right here. So then let's go. It's not too exciting. We'll go over here to the grid. So, and it's important to note that I have a view pager in there, and I have one fragment with one layout, and then it's just configured a little bit differently for each tab. The fragment is not, the layout just has one RecyclerView in it. And so I just basically tell this RecyclerView, hey, be a grid. And I'll get into more of that later too. But so it's doing, and this is just like kind of a standard grid, and you can scroll through it, and it doesn't have anything special in it, but it gets a little more exciting when we go here, where we have, now we're implementing this heading. So maybe you want to show groups, and you want to delineate between, maybe this is like top charts or something like that, and then the next one is like maybe, new releases or something like that. And you want to be able to have this kind of visual, and it's kind of hard to see this color here, but there is a divider there. So that's cool. But then let's get a little crazier, and then let's see here. These bigger items are just randomly added. That's what I have right now. But so here's one where it's just, you're getting this nice, everything's lined up correctly. See, the gutters are nice and aligned here. The height is aligned here, and things flow around the bigger item. And that's actually, I've tried to do this in the past with GridView, and it's possible, but a lot of work. Not so much work with RecyclerView. Okay, and then I'm gonna go one more little bit of craziness. This looks kind of the same, but if you look at this first row here, there's a little bit of, it's kind of bleeding off, which implies that you can scroll this. So this is going to be, this first row here is actually a recycler view inside of a recycler view. And then I have these items that are spanning. So as we go through here, here's these lists that come through like this. And I do this just to show that it can really handle pretty much any situation you throw at it. And the way this is implemented, again, you can see this in the, if you look at the source code for the demo, but this is just an item that I've told the outer recycler view, hey, this thing spans all of the columns. And then this item itself happens to have a recycler view in it, and I've set it to be in a horizontal orientation. So then now you have, and that's one thing that you never got with the standard widgets, was a really good horizontally scrolling view, right? You have horizontal scroll view, which all it does is take one child and kind of moves it around. But it doesn't work with an adapter, so it's really hard to have page data in there. But with this, it works just like an adapter-backed view. So you could page load it, you could infinitely scroll, you could do all sorts of stuff. So that's as crazy as I got with this. But then one last thing, let's go back to the beginning. I'm just gonna show you all the things that the demo does at the beginning. Okay, so I have a little plus button here, and a lot of times you wanna let users add or remove items. And it's not that hard to actually add or remove item, but usually it's hard to get it to look like the item is adding as opposed to just appearing. But RecyclerView lets you do stuff like this. That one, maybe this one. And it's the same thing with the grid. It does a really nice job of letting you add these new items here. It scrolls them off, you delete them. And this is all like pretty much for free. There's default animations. As long as you're calling the right things, it'll animate that stuff for you. And it works with any one of these, even the really complicated one here. Although I only have it, I could have had it adding things that span, but right now it's just doing the one single item at a time. Okay, so that's basically my demo reel of why you should be using it. Hopefully I've convinced you by now that it's something that you might want to start looking at using. So let me switch back here. We'll get into how I did some of that stuff. And this is just reiterating what you just saw. You can do simple lists, you can do simple grids, you can do grids with group headings, you can do a grid with headings and multi-column items. You can do all that with nested horizontal lists. And it's pretty nice. So again, why should you use it? It's pretty awesome. It's very flexible. It's in the support library, so you don't really have an excuse, compatibility excuse to not use it. And ListView and GridView are terrible, and they make you sad. Or they make me sad, at least. All right, so let's get into the anatomy. I think it seems, at first glance, it seems, well, maybe this is a little different, but it's pretty much the same as what you're used to using. There's the view, there has an adapter. It serves basically the same purpose as a ListView adapter does. The new things are here, the layout manager and the view holder are basically the two new things that you might need to get familiar with. So I'll just dive into each one of these. So the recycler view knows how to recycle views, and that's it. And by that, I mean that it only knows, it works with the layout manager to know when a view is either going off screen or coming on screen. And it knows whether it needs to put that particular view or view holder in a scrap heap or take it out of the scrap heap or ask for a new one to be created, things like that. So what they've done is they've extracted all of the layout logic from the view itself, which is what the big problem with ListView and GridView were, is that they had to recycle the views and know where the views need to be laid out. They fixed that now. So the layout manager is where the real magic happens. But basically, the recycler view is what you put in your layout. And it's not a list or grid. It's not horizontal or vertical. It's everything. It just depends on what layout manager you give it. So the adapter, yeah, is conceptually the same thing that you're probably already used to. It provides and binds view holders to be displayed. And so view holders, some of you are probably familiar. It's like a best practice that they've had in the Android documentation or developer guides for a long time. And I'll give you an example of those, but they're really just kind of wrappers around your view. So here's, so you can see this. This is just like a kind of pseudocode skeleton of a RecyclerView adapter. And if you look, it's pretty much what you would expect from a regular adapter. You have to implement an get item count. And the difference is here is rather than just a get view, you have on create view holder and on bind view holder. Get view, you have to check the passed in convert view. If it's null, okay, let's make a new view. They've separated that out, so it's kind of nice now. You know here, always make a new instance. You know here, this will never be null. Do your binding, and everybody's happy. And then one more thing that's cool about, you don't have to implement, but what makes it much more powerful is this view type they're giving you. This isn't, when they say create view holder, they don't give you a position to create it for. They give you a view type. So get item view type is similar to the one that's in the regular adapter, but it's more powerful, I think, because it lets you make like what I have in the demo where some items are a different layout than the others. And the best way to use it is return a layout resource ID for that position. So when your on create view holder is called, what you return here gets passed in here, and then you can just inflate it. Pass it to your view holder, boom. So there's no looking up, oh, what do I need, what view do I need here, whatever. You've already answered that question. The view at that position, you've already answered it. It's telling you at this point, I need this view created for me. So, and it's also, I have notes for that too. I'm in the view holder. So also note that there's get item view type, but there's no get view type count. You don't have to know ahead of time or any time. You don't have to tell the RecyclerView how many different views you're going to have. It doesn't care. Internally, it's creating like a partitioned caches for each different view holder. So based on what you return here, from here and then there. Okay, so view holder. This is getting towards the last piece. Excuse me. So the view holder should sound familiar. Like I said, it was an established best practice, but now they're actually enforcing it, which is a good thing because it'll make your lists that much more efficient when you're scrolling. So it acts as an access wrapper around your item views. So the view holder itself is just like, it really doesn't do much. You give it, when you're asked to create a view holder, you inflate your view, you give it to the constructor of the view holder, and then in your constructor, you should do all your find view by ID calls and assign them to member variables of the view holder. So for example, if your view holder has an image and like a text field, your view holder class might have a member variable that's, excuse me, a member variable that's a text view called like primary text, and then an image view called, image or whatever. So then in your constructor, when you're creating the view, you have to look them up, and then you would add accessors to your view holder subclass that are like set primary text, set image URL. And then what your view holder is gonna do is check to see if it's that view happens to be non-null, and then set whatever property on it that you wanna do, which makes the view holder very flexible because you could use it with different layouts. If it doesn't find the image and you're null checking that, it just doesn't find it, you don't set it. So you can still use a view holder, but it just lets you kind of selectively use layouts. So here's a kind of a simple example of a view holder. So you extend the RecyclerView view holder. The only real requirement there is that it has a constructor that takes a view as a parameter. So what you do here is you find your text view, and then you'd make an accessor here to set the text. Because generally, you don't even really ever need access to the actual text view itself. You probably just want to set the text. And then you can make things like, hide it, show it, stuff like that. But it also like makes a nice description of what this view holder is supposed to do, because instead of just I like to do it this way, but instead of just exposing this, you expose like specific things that you want to do with that view. Set primary text, hide primary, something like that. And then since you're null checking everything here, it's just a nice clean way to use it with different layouts. If that view happens to be missing, this thing will still work. We'll just bypass that view. So now, Layout Manager, which is kind of the meatiest part, it's definitely the most complicated if you look at the source for it. It's a lot. There's a lot going on in there. It's very similar if you look at ListView, the ListView implementation, all the crazy stuff it's doing to try to figure out, like, or GridView is even crazier, but to figure out where these things need to go. That's been pulled out into Layout Manager. And there's different implementations of it. The good thing is that they've added standard ones, and they're all pretty, like they cover pretty much anything you could throw at it. They have a linear layout manager that's for a list. They have a grid layout manager that's for a grid. They even have a staggered grid, which I didn't show in the demo. I didn't run out of time when I was making it, but so you can do like cool Pinterest and Etsy style staggered grids, and that layout manager knows how to do it. So if your grid items are of varying height, it knows how to pack them correctly. But so it also, they can easily be switched. There's no like setting up in the layout, oh, this Recyclerview is going to be a grid, and that's it. This Recyclerview is going to be, you don't do that. So you can switch it at runtime, so you don't have to do a view switcher, which is like, this is kind of the classic way of saying, oh, well, this view, sometimes it's a grid, sometimes I want to show the data as a list. You do a view switcher, you put the two in there, you switch between the two children. It's okay. But not as great as just putting a Recyclerview in there, and that's it. So it's just a little bit simpler, rather than having to be like, because if you have that view switcher, then it can only be that list or only be that grid. This could be a horizontal grid or a horizontal list or whatever. You know, you're not defining it here, you're defining it at runtime. So it lets your user potentially configure the user interface a little bit more. Okay, so we'll get into kind of putting it all together, making a simple list and a simple grid. These are like the three things you have to do. Put a Recyclerview in a layout, you set the adapter on it, you set the layout manager on it, and you're done. So I think I have some code snippet here. It's kind of hard to read, I bet, for people in the back. But basically what I'm doing here is like, this is an onCreate view of a fragment. Just inflate your view, find the Recyclerview. Say you have a member variable or something that's like, hey, we're showing it as a list right now. So this is like, here's the magic. Just set layout manager, new linear layout manager, you're done. Or grid layout manager, and then you tell it how many columns you want. And this is cool too. It's similar to setting num columns on the grid view. This value could be like I like to put it in an integers XML. So for landscape, maybe you have 4 columns, and then for portrait, you have 2 or 3, something like that. And then here, assuming you have data at this point, you set the adapter, and then you're done. Well, if you had to have created those view holders before that the adapter is going to give to the Recyclerview. Okay, so now we know how to make a simple list, a simple grid. We want to be able to do the cool things where you have things kind of span rows or columns and all that stuff. So I'll show you how to do that. It's pretty simple. So there's a thing, I think I screwed up this name, but it's in the code, it's right. It's not in Recyclerview, it's in Grid Layout Manager. So there's a thing called span size lookup, and it works with a Grid Layout Manager to figure out how many columns an item should span. And the span means, like a span of 1 means I live in 1 column, and so on. So 1, that means I don't span anything. Any more than that means you need to accommodate me however many spans I want. So here's like an example. I have in my adapter, I just made an implementation of the span size lookup. I put it in the adapter because it's going to be ask you for this position, what's the span size, and since the adapter knows about the data that it's putting into the view, it seems like a good place to put it. And then here it's just like, okay, check your layout manager instance. If it's a grid layout manager, then set the span size lookup, get it out of your adapter, just set that, and then you're done. And I want to put out here that it says view models. I use the MVVM pattern. I think there was a talk about it yesterday. I highly recommend it, because here it kind of extracts the information from your data model into like a view model, so it's just for display. I put span count in there, I put a layout parameter on there, and it makes it really easy for your adapter just to be like, for this view model at this position, it doesn't have to make any decisions. Those decisions are made way before this even happens, because the thing that's actually handling getting the data converts them into view models. But that's a separate conversation. So back to this. So now, basically, what I just showed you lets you do this. That's it. Span size lookup. You set it on. If you're using your grid layout manager, you set it on there, and you can do things like this. And then the last piece is modifying the list contents and getting those nice animations. Because it's just nice to be like in a good responsive app, you're gonna show like you're adding something that looks like it's getting added, it looks like it's getting removed instead of just appearing and disappearing. Traditionally, you have to do a lot of heavy lifting to do that. ListView doesn't really handle items that are animating very well. Fortunately for us, Recyclerview is gonna come to our rescue again. So here's the old way, potentially without an animation. You have maybe a remove item on your adapter, you remove the model from the data set, you notify data set changed, the list updates. The problem with this is your data set observer, in this case your ListView, all it knows is that the data set changed. It doesn't know what changed about it. There's no context. It's just, you're like, hey, something changed. But you don't know, like, was it removed? Was it added? Did something get swapped? Did you just update the contents of one item or a range of items? It doesn't know. So the only thing the observer can do is just say, well, I better just redisplay all the things that are currently on screen, which, I mean, works, but it's not super great. Now we have all these new, really nice API for actually telling the observer, in this case, Recyclerview is the data set observer, you can tell it exactly what happened. Oh, hey, an item changed, you give it a position. An item was removed at this position. An item was added at this position. There's also more. There's like, you can say a range of items have changed. You can say, I think there's one for telling that things have changed positions or been swapped. So now that the Recyclerview has a way of knowing exactly how the data set changed, it can do something smart like animate the change, because it knows exactly what happened. So that's why you get these default animations, and you don't have to do anything to turn them on. They're already there. So this is all you have to do from that previous example of the old way. This is the future, where you just say, you know that someone removed an item. Now you can tell the Recyclerview that this item was removed or this item was added. This is all I had to do in that to get those nice adding and removing animations. The grid one, where it kind of puts them in place. This is all you have to do, and it just does those animations for you. I'm going to go back to my cool animated GIF just to reiterate, like, all you have to do is use the right notify methods, and you get those nice animations, just like here. I think I took these off the GitHub repo, so that kind of shows it. But so there you go. That's probably one of the coolest things, is you really don't have to do anything to get that. Yeah, it's coming to an end. I didn't go my full time, but I'll just recap that Recyclerview is the future. You should be using it, or you should at least be thinking about using it. Use it in a new project, maybe. Think about converting your existing projects, because the API is very similar. Your adapter is not really going to change very much. You're going to have to use ViewHolder, but that's not a hard thing to implement either. And then you're going to get a kind of this way cooler, a more powerful view. That's about it. Yeah, I mean, I've covered the modification. The ViewHolder pattern is enforced, which is great, because now you're not, if you're doing all your find view by ID calls in the constructor, then every time you're binding the view, you're not calling find view by ID anymore, right? And you only have 16 milliseconds between frames. Why waste them calling find view by ID again? That's just, you're just kind of come right up to that boundary where you're going to drop a frame, and then you don't want to do that. Yeah, so that's it. I didn't make a last slide, so let's end of show.